Welcome everyone to Financial Mathematics 211, that is A211 or CM1 of the of ASA, or the Institute and Faculties of Actuaries. Today we'll be looking at level annuities. But before we do, you can check our description below to learn what we are all about, ASABA, and please subscribe to the channel. Okay, here we start. So before we can start, I would want you to have a knowledge, or at least a background knowledge, about interest, time value of money, discounting, and accumulating factor. Because if you don't have this background knowledge, you may not understand what I'm about to do. Alright, let's start. Level annuities, part 1. So this series of video is has 4 parts. So this one is the first part. We will be looking at finding the present value and the accumulated value of a series of payment. That is, we will be looking at the present value of a series of constant payment, as well as the accumulated value of a series of constant payment. So what do I mean? Let's say perhaps you are looking at the present value of a series of payment of 1 rand for the next 4 years. 1 rand at the end of this first year, and then 1 rand at the end of the second year, 1 rand at the end of the third year, and 1 rand at the end of the fourth year. How much money is it equivalent to at the present time? So as you can see in the in this picture, I've shown you that there's 1 rand, which 1 rand at the end of time 1, which is discounted back at time 0, and then 1 rand again at the end of time 2, which is discounted back at time 0, and then 1 rand again at the end of time 3, which is discounted back at time 0, and then 1 rand again at the end of time 4, which is discounted back at time 0. All this is equivalent to that 1 rand at the end of first year is equivalent to 0.9 cent, and that 1 rand at the end of the second year is equivalent to 83 cent, and then 1 rand at the end of 3 years is equivalent to 75 cent, and then 1 rand at the end of the fourth year is equivalent to 68 cent. That is, the present value will be 3 rand and 17 cent. But then what happened when this payment continue for a longer time? Will you keep on discounting them individually? Well, no, because we will have to find a formula, or a simple formula, or we will have to make a simple formula which will allow us to find this which will allow us to find this present value with ease. So let me wait for this thing to load. So as you can see, let's say this payment continues up to time n. We don't tell you what is time n. It could be any number. So again, we will say that the present value, right, will be equals to the value at time 1 discounted back at time 0, the value at time 0 which is discounted back at time 0, and then you continue forever up until you have the value of at time n, which is discounted back at time 0. That will be the present value. So let's find a simpler way of understanding this. So V, by the way, as you can see here, V is the discounting factor. So V1, V2, again V2 to the power 1 is the discount factor of 1, V2 to the power 2 is the discount factor of 2. So let's find a simpler way of writing this formula. So when you have knowledge of sequence and series, you will know that this thing is a sequence. This thing is again here is a series. So you will have the first value 1 minus the ratio, which is V, because term 2 over term 1 will be V, right? So that's our ratio. So you will have V to power n over 1 minus V to power n. Let me zoom in a little bit here so that we can see. And then you will have 1 minus V to power n over 1 minus V to power n all over V when you take this V here. So at the end you will have 1 minus v to power n over I. So this is a simpler formula which you can use to calculate this payment of series of payment up until time n. Okay, let's look at so this is the formula we have. So this 1 plus I all to the power negative n is actually v to power n. Let's say what happens when payments are made in advance. At the first example, we have looked at payments which are made in the beginning, like at the end of the payment. That's payment made in arrears. So now we have to look at payment made in advance. So this is the formula you will use to find the series of payment which are made in advance. The present value of a series of payment which are made in advance. How about the accumulated value? Again, this is the formula you will use to find the accumulated value. But then again, we look at the same scenario. What is the accumulated value of a series of payment, which of a series of constant payment, so which are made in arrears. So this here on your left hand side, on your right hand side, is the formula of finding the accumulated value of the payment made in arrears. And then here again is the accumulated value. Is the accumulated value formula of finding series of payment which are made in advance. So let's look at a couple of examples. So I will give you some time to do this example and check if the answer is the same. But then we will just do it now. So for number 1, we're looking for the present value of a series of payment of 50 rand which are made at the end of the year, or at the end of each year for 17 years. So that means we have 50 rand, right? And we're looking for, so these payments are made at the end of each year. That means they are made in arrears. So when they are made in arrears, we will use this formula, which does not have dot on the top. So for 17 years, here's the period, 17 years. Given that the interest rate is 10% per annum. So how do you find this again? So it's going to be 50, 1 minus 1 plus I to power negative 17. That's the period all over I. And in this case, I is actually I is interest, which is 10%. When you punch this in your calculator, you have 1 minus 1,0, 1,1 to power negative 17 all over 0.1. You have 50 times 8,021553311, which will be equals to for 01,08. There it is. So when they say find the accumulated value, there are 2 ways you can do this. You can just say the present. You can just say the accumulated value will be 401,08, and then accumulate it again. Accumulate it to the future. You would have 1,0 to power 17. That will be 20, 27, 24. All these are in rent, the current rent. As you can see, these payments are equal. So let me know in the description if you find the same answer or if you have correction. Okay, so I will let you do this one on your own. You can pause the video and find the answers for this question, and then let us know in the description what your answers are, and then help each other. You can correct each other and comment. Thank you guys for watching this video. We are ASABA, and you can follow us on our social media pages. We will leave the details on the description below. Yeah, that's it.